Good morning to another exciting day on our Intelligent Industry stage. Today we focus on sustainability, and I'm very happy to announce the next slot, which is on sustainable hydrogen technologies. So let me welcome my colleagues Andreas Kötter, who is the lead of research and innovation in Capgemini, and Capgemini responsible for applied research, and Dr. Oliver Hegen, who is heading hydrogen technology research in Capgemini. They will speak about hydrogen technologies and how we use how we help with digital technologies to make hydrogen happen. So let me introduce the colleagues and the panel here.
Thank you very much, Lydia. Thank you very much for this short introduction. My name is Andreas Kötter. I'm leading our research and innovation activities within Capgemini Engineering in Germany, out of which, of course, the sustainability topic is quite a very big one. We all know it, we all heard about it. If you walk around the fair here, sustainability is all over, so is hydrogen. This is why I'm very happy why I have my colleague Oliver with me as well. We're going to introduce this topic in the frame of what is currently going on, what are we able to offer, and how to get in touch with it, why to do this. And the why, of course, is always the most significant, the most relevant part. Why should anyone go for sustainability besides climate change, etc.? No, it's all about the wallets. It's all about the money. And if we look at, for example, and this is what we're showing here, the price of the CO2 certificates, how they rose during the last years. Of course, there were some interference during the pandemic, during the war, etc. But all in all, there is a clear trend. Yeah? If you have a huge CO2 footprint, it will cost. Yeah? And the cost will rise significantly. And this is why most of the customers, most of the people, most of the businesses look into new ways on how to avoid such costs. So what are we doing in this frame? We have 5 main pillars in the frame of sustainability. Of course, if you've got a dedicated product, then it is the easiest way to, first of all, look into the product itself, look into the materials, the processes, etc., get some feasibility, get some transparency on the product itself, deep dive into it, not only within your facility. If we look at the supply chain, the value chain as such, of course, there's way beyond that what's going on during the final assembly. But this can be visualized as well. So we need this kind of transparency, deep dive into the product itself, into subcomponents and subcomponents and more subcomponents even, and then identify at the first stage the hotspots. Of course, this always needs to be in line with a dedicated strategy, a robust strategy, in order to ensure circularity on the one side with existing products, but on the other side, we need to rethink products as well. And there it comes the sustainability by design into place. What does it mean? We start off with a new development of a very new part or component, whatever you name it, and apply sustainability topics right up front. This means not only life cycle assessments, end-of-life assessments, etc., but even more the life cycle costing. And the life cycle costing means I have a dedicated value, I have numbers, I'm able to calculate the added value of the product, of the component that I'm currently developing. Of course, in parallel and all over everything, there's always the innovation. We are dedicated to, we're curious about innovation. I'm leading our research and innovation department, which means we have something like 25, 28 research projects ongoing in which we develop very, very new technologies together with our customers, their supply chain, research institutes, and also universities to develop new disruptive technologies, but also to further optimize ongoing technologies. So where are the main hotspots for now? And this graph is not a big surprise, as we can see here. 3/4 of all the sustainability hotspots come from the energy stationary, but also from the mobility sector. Yeah, we will deep dive into this later on as well. Of course, many people speak about agriculture, the industry itself, but if we're speaking about a real game changer and the possibility to change something bigger, then we're speaking definitely about the energy supply. Yeah? And as such, with this I would like to hand over to Oliver as well. We have a clear view on where to generate the energy that we need, especially for the future. Oliver.
Thank you very much, Andreas, and thanks for having me here at the Capgemini stage. So energy is really an important topic, and we should take a closer look into that, especially into hydrogen. People are saying hydrogen is the green energy source of the future, the green energy carrier. But is it that really? Can hydrogen pave the way towards climate-friendly technologies, towards climate neutrality? So if we now take a closer look into the electricity mix, for example, for Germany, in 2022, we had a carbon footprint for every kilowatt-hour electricity of 434 gram CO2 equivalents. Sure, about the half was generated based on renewable electricity generation, but the other half was based on conventional generation. That means gas, natural gas, nuclear, and also coal. In comparison to that, let's take a look at the renewables. Solar mix, for example. There, we have a carbon footprint of 122 gram CO2 equivalents per kilowatt-hour electricity. And then, let's take a look at wind. There we have 32 gram CO2 equivalents. And now you would say, stop. Let's take a closer look at that. Usually, renewables should have a carbon footprint of almost 0. And basically, you're right, during the operational phase. But we also have supply chain, we also have the production. And this is why the carbon footprint is like that. And now, let's compare renewables to hydrogen. Hydrogen produced from renewables. And for that, to have really a comparison here, we took the system, which you can see here on the right-hand side. So we start with 100% renewable energy. We produce hydrogen with a PEM electrolyzer, and then again convert it into electricity with our fuel cell with an efficiency of 45%, and we end up with 32% of electricity. So we start with 100% renewables, we end up with 32% electricity again. And if we now take a look at the carbon footprint of hydrogen based from our solar mix, it is nearly equal to the one coming from the electricity mix in 2022. In comparison to that, wind, there we have about 144 gram CO2 equivalents per kilowatt-hour electricity. So what you can see here is that currently wind is, especially when we talk about CO2 equivalents, CO2 emissions, it is more efficient than solar. And why is that? Well, again, it is supply chain, again, it is production. But not only for the renewables, that means solar panels, wind turbines, but also for the hydrogen technologies, that means electrolyzer, and that means the fuel cell itself. And if we now take a closer look into that and dive a little bit deeper into that, you can see here some common hotspots along the entire value chain of hydrogen technologies. So we talked about the energy source, and for sure, energy is the most important part. But there are other important parts. For example, the storage and the distribution of hydrogen. Well, it makes simply a difference if I produce hydrogen onshore and use it directly there, or if I produce hydrogen via solar panels in the MENA region, for example, and then transport it into Central Europe and use it in Germany. it makes a difference if I store hydrogen at 300 bar or if I store it at 700 bar, or even if I transfer it into liquid hydrogen. So please keep that in mind. Another important hotspot is the balance of plant. And this was quite surprising for me. The balance of plant is more impactful in terms of the carbon footprint than the electrolyzer stack or than the fuel cell stack. And why is that? And this is what you can see here, and this is what we usually see here when we dive deep with our life cycle assessment into hydrogen technologies. So the balance of plant makes about 84% of the carbon footprint of an electrolyzer system or a fuel cell system. And now, if we just take a closer look into the balance of plant, we see that it's there the electrical system with over 50%. And in the electrical system, it is the battery and it is the inverter. So that means now we have identified the carbon footprint hotspots in there. We know where we need to optimize. We know where we need innovation. But that's not all. That's just one part of the acceleration of the hydrogen market ramp up. There is a lot more, really. And the first question we usually have when we talk about hydrogen with companies is that, how do I make money with hydrogen? Where do I use hydrogen? How do I use it best? What about standards? What about regulations? What is currently going on in the market? And for that, to answer these questions, it is highly important not only to have the technical expertise, but also the understanding of the market. The second question is the question of efficiency. And when you think back towards our electrolyzer fuel cell system, the fuel cell, the PEM fuel cell system, we made the assumption of an efficiency of about 45%. So we should go higher, definitely. And how can we do that? Well, the question is, how can we use the heat which is generated due to the electricity production in a fuel cell better to become more efficient? What about safety? What about the topic of hydrogen embrittlement? Here it is highly important to use the right materials there. Also in terms of degradation of hydrogen technologies, when you think about the membrane, for example, in a fuel cell or the PEM electrolyzer, aging, maintenance. Also, these are the questions of efficiency. And the third topic, and this is clear, is the market ramp up and the scale up of hydrogen production facilities. So we have a rapidly growing demand of hydrogen, and currently about 99% is coming from fossil fuels. But we don't want that. We want green hydrogen. We want low carbon hydrogen and not fossil fuel based hydrogen there. So we need to become more cost efficient. We need to become more eco-efficient, and we need to set up sustainable supply chains. We can answer most of these questions, but not all of them. And with that, I hand over to you, Andreas.
Yeah, indeed. Coming to the questions, it's always me who's been asked for whatever reason. However, there are, of course, many open questions. We've heard it a lot. It's all about the costs. How can we use synergies? This is what we are currently looking at. Yeah, especially, these huge platforms like Catena X, for example. Yeah, we're currently developing something like, or in the frame of Catena X, we're developing together with the aerospace industry, in which we are using these kind of synergies as a platform, take over some of their solutions, add our new ones. But there are many others. Yeah, looking at the hydrogen market, it's of course about storage. Yeah, we're currently looking at. We're even looking about at quantum computing. Yeah, what the hell does quantum computing have to do with hydrogen? A lot actually, because we are trying in an industrial application. We're trying to bring all these the BOP into a dedicated software, into a system that we will be able to scale, to test, and further integrate into the final solution at a later stage. Yeah? And using quantum computing saves a lot of time, yeah, and offers us way new possibilities in order to newly develop these kind of new technologies. Yeah, last week we have been discussing a huge European call. On European level, there's a so-called public-private partnership. It's called the Clean Hydrogen Joint Undertaking. The European Commission knows quite well where we're leading to. Yeah? They are asking us many questions. I'm myself member of the European Quantum Coordination Board, in which they ask, okay, what do you need money for? What are the main topics of research that you would like to address, especially here in the Clean Hydrogen Joint Undertaking? And of course, we're answering this. And then, as of this, we're developing new solutions in joint projects. Yeah? And this is, I think, one of the main pillars that we are currently building up our innovation energy, our innovation pipeline on. Yeah? And definitely hydrogen is one of the very and biggest ship that we are currently leading.
Definitely, definitely.
Good.
So with that, thank you very much. And we're looking forward to your questions.
Thank you, Andreas and Oliver. So I'm sure the audience has some questions for you. Any questions for Oliver and Andreas? If not, I start with the first one. So all this new research, it sounds fancy, but if you're a corporate institution, how do you start this? How to get started, Andreas?
Indeed, actually, we started off with this topic, meanwhile, I think 14 years ago. And it was by accident, by coincidence, because we knew a partner who was supposed to develop something very new that we were quite curious and interested about. And then he asked us to join. It was actually, at that time, it was the DLR, the German Aerospace Center for Research. So, meanwhile, we have all the capabilities. So whenever you're interested in such joint research activities, yeah, lifting new technologies to a demonstration level, to TRL 6, sometimes 7, which makes it scalable and integratable afterwards. Basically, what you need is just one partner who can guide you. And we can offer this guidance to whomever is interested in this kind of topic, because we know, first of all, how to do all these application stuff, how to execute the work, the organization, the administration. Everyone is always quite scared about that. You should not be. After a while, you get to understand the way of working on European level, also on national level. It's not that big difference. Basically, it always works the same. And of course, the exploitation that we can generate out of these research activities. We as Capgemini especially, because we're not just focused on one industry, but on several. And whatever solution we are developing will find its way into other industries as well. Yeah. So if you've got a partner who can guide you there, we will be happy to do so. And this definitely helps you to generate these additional budgets for innovations.
Further questions? If not, they are still around. We have, in the experience area, an example of the research you do, and we invite you to come by and ask your personal questions.
Perfect. Thank you very much.
Thank you.
Thank you.